Okay, so let's continue with our mensuration example 1. We now go to question 4. Question 4 is the area of the 80 millimeter thick interlocking paving bricks, and that will be the square area, meaning we are looking at this square area as the paved area. Right, we will write our word picture, 80 millimeter thick interlocking paving bricks. We're going to work with area, which is square meter. Right, and the formula for a square's area is width times length. Okay, which is then 2.50 by 2.50 equals, do you see, area has got two lengths, so I need two lengths before I get my equal sign. That times that gives me 6.25 as my final dimension. Okay, let's go to our next question, question 5. The area of the kukui grass on well compacted sand layer. Right, the grass, remember this was a paved area, that is a water feature, so the grass is whatever is left after those two areas are subtracted. Right, let's first read or write our word picture. Kukui grass on well compacted sand layer, again square meter. Right, but as we now said, it's the whole area, and then we must subtract these two areas, and then we will get whatever is left as being the grass area. There's my cat. He's just come into the house. Okay, back to the basics. Right, so we're first going to look at the area, the total area for the shape, which will be 40.00 by 16.50 equals, remember, two measurements because I've got area there, equals 660.00. Right, but then I need to deduct the area of the paving or the square, and you'll see I'm going to write DDT here over the times and the dimension column like that. Right, the area of the square is 2.5 by 2.5 equals 6.25, and because I'm deducting, I'm putting it in brackets. Right, then the area of the water feature, that means a half circle. Again, the area formula for a circle is pi r squared, and I only need half of it. The half and the pi must go into the times column, and I need 2 r's or 2 dimensions. The radius of the half circle is 1.25 by 1.25 equals. So again, there is my two measurements for the meter square. Right, remember this is part of the formula. If I've calculated that, that will be 2.45 and in brackets because I am deducting it. So now I will go and say 660.00 minus 6.25 minus 2.45 equals a total of 651.30, and that will be my final measurement. Right, so I took the big square or the big rectangle and I subtracted the two shapes of the paving and the water feature to get the total for the grassed area. Right, let's see. Question 6, we are now going to calculate the volume of the water feature or the half circle. Right, and then there's very important information with the volume. It says the depth from the top of the paving or the grass to the bottom of the water feature equals 1200 millimeter. Right, remember when you fill something with water, it's never level with the surrounding hard structure. it's always that bit lower. So the water level is 85 millimeter below the paving or the grass level. And there I've drawn you a picture. So there's your paving or your grass level. This is the total height of your water feature, but the water is only up to there, 85 millimeters below the level. So if I want to know how much water do I need to fill this water feature, I must only calculate the water part. I can't calculate the air as well. Right, so let's write our word picture, the volume of water in the water feature. I can quickly make a small side calculation here with a little picture. Remember, you can use this column to draw pictures to make things more clear for yourself. Right, side calculation is going to be 1200 minus my 85, which gives me 1115 as the depth of my water. Right, as you can see from this side calculation and my previous side calculation, when I do side calculations, I keep it in millimeters. Only when I move it to the dimension column do I put it into 2 decimals meter. Right, we are now working with volume, so cubic meter. Right, in other words, we need 3 dimensions before our equal sign. Right, again, if we think nicely about it, area times depth equals volume. Right, so it's going to be the area of my half circle times the depth. As in the previous one, we've already done the half circle calculation. So it's a half times pi times 1.25 times 1.25, that's my r squared, times my side calculation 1115 meters 2 decimals becomes 1.12. And then I'll have my equal sign, and if I do that whole calculation, I'll get to 2.75. And that will be my final calculation, and I will end off my takeoff. And as you can see here, where I start my word picture, right next to it I start writing my dimensions. And I can do whatever, and even if my dimension ends earlier than my word picture, I only put my finishing off lines, take off finish lines at the end of everything, so that I know that everything that's inside these lines, they belong together.